Hi, my name is Tom Johnson. This is a recording of a webinar that I gave to the STC Southwestern Ontario chapter on February 2, 2015 on the topic of API documentation. This presentation's title is Survival Strategies for API Documentation, and it's similar to some other presentations on API documentation I've given, but it's more compressed into a 1-hour format. I hope you enjoy it. If you have any feedback, send it to me at tom@I'dRatherBeWriting.com.
All right. Well, thank you, Jim. I appreciate the introduction. And I'm excited to give this webinar. This is one of my favorite topics, and it's definitely one of the most interesting in the TechCom space right now. There was a survey done by one of the leading websites that looks at REST APIs, web-based APIs, called Programmable Web. And they were looking at, or they were surveying programmers to find out what are the most important factors in API documentation. And the number one most important factor, as you can see at the top here, is complete and accurate documentation. And there were more than 250 or so respondents to this, so this wasn't just a small kind of one-off survey. Documentation really is a huge deal in API documentation. One of the founders of Programmable Web gives presentations, and he kind of talks about these results. And he said, he lays it out. He says the number one reason why developers hate your API is because your documentation sucks. And really, the API doc world presents all kinds of newness to technical writers. It's usually a space that engineers typically create and contribute documentation in. Tech writers aren't necessarily power players usually in this space. So when we enter the API doc world, it can look like Mars. It can look like something totally new. The tools are different. The audience, being developers, are often different. The language, the lingo, the way people interact is different than what you may be used to when you're documenting something that has a graphical user interface. One of the reasons, this is actually a job ad on Indeed.com, and you can see here that I've highlighted a part that caught my attention. This person says the client wants to find someone who will emulate Dropbox's developer documentation. And you can see Dropbox's developer documentation here. It doesn't look so fancy, but it is actually very well done. And one of the reasons why the documentation and the interface for APIs are so important is because there is no graphical user interface that people interact with. Docs are the interface. You learn about the different endpoints and different calls that you can make through the documentation. So it's important that the documentation is accurate and complete, but also that it sells the product, that it looks good, and that people can easily find things. So that's why I think technical writers this is a ripe opportunity to step in and provide or to use our expertise in organizing information, making things clear, finding out those details that engineers often overlook, and adding them to the documentation. As Jim mentioned, I did edit an intercom issue because I felt there's a real dearth of information about API documentation in the TechCom space. Actually, Liz Poland, the editor, wanted to do something on trends, and I said, well, a huge trend is API documentation, and we should really focus the whole issue on that. And so you can actually download this whole issue, regardless of whether you remember. There's a link on my site for it. Somebody was allowed to add it to Dropbox, I think. So a little bit about me. I started doing API and SDK documentation a couple of years ago. I feel like I'm still learning a lot, and there's a lot of things I simply don't know. There's a lot of different technologies and tools and platforms and programming languages in this space. And so usually people maybe become experts in one sliver of the pie. But I'm not a programmer by trade or anything. I have an English major, creative writing, master's degree. I love to write. I like code, but I'm not necessarily a coder or programmer. And of course, I have a blog and podcast that Jim mentioned. So let's get into some basics about the API landscape. And by the way, if you have questions as we go through, feel free to jump in. You can also use the chat, although since I'm in slideshow mode, I probably won't see it, but I'll check it every once in a while. But yeah, feel free to jump in and ask questions. Alright, so some basics about the API landscape. An API is essentially an interface between two systems. It helps kind of it helps the two systems talk to each other. Common example maybe is a Twitter stream on your web page. You put some code on your web page, and all of a sudden it's talking to Twitter and pulling the latest tweets on your web page. That kind of interface is what we're talking about. And there are lots of different kinds of APIs. We're going to talk briefly about platform APIs. These are library code bases that people download and incorporate into their projects. Kind of like with JavaScript, if you want to leverage certain JavaScript functions, there's often a JavaScript library you need to download. It's the same concept. REST APIs are different. They're more like how the web works. You don't download anything. You send a URL across the web using HTTP, and you get a response. There's also a term that you'll hear, SDK, which stands for Software Development Kit. By the way, API is short for Application Programming Interface. An SDK is kind of a companion to an API. It's tooling and other specific implementation mechanisms that kind of make it easier to work with the API. A good example, when I worked for a gamification company, we had a REST API, but most of the people implemented the gamification using web pages, and so they used JavaScript. And in order to make it easier for people to make the calls to the REST API, we also had a JavaScript SDK that would allow people to call the REST API in familiar JavaScript syntax and more easily process the response. Now there are at least two deliverables. In the pre-webinar chat we were talking briefly about this. There's traditionally an API reference material. Somebody mentioned that they have some reference material generated through Sandcastle. But then there's also user guides. And technical writers definitely play a huge role in the user guides. The user guides tell people how to work with the API. They tell users what calls to use and what sequence and what the workflow is to do real tasks. Whereas the API reference is a list of the classes, the methods, all the technical details, not necessarily task-based at all, just a list of what the API can do. So the two complement each other. And a lot of times engineers will drive the reference information while technical writers write user guides, although technical writers often help out in the reference, and some write the reference entirely as well. I want to talk briefly about platform APIs before transitioning into REST APIs. There's a concept with platform APIs called Autodoc, or a document generator, and it works very similarly to document generators you use for help authoring tools. You know how if you have Flare or RoboHelp or Author-it and you create a series of help files and then you publish or compile it, you get a little website that you can publish. Well, there's a similar concept in the API world, and the way it works is in the code base that people have, for example, with Java, they put in some special syntax, a slash with a couple of asterisks followed by more asterisks, an @ symbol with param, @ symbol with throws, and then these document generators will look through this syntax, parse it, and push it into an output. So a lot of the platforms, Java, C++, .NET, PHP, Ruby, they have auto document generators that will allow people or allow engineers to write in the code, write documentation in the code, and then generate out a reference document that has this. And one of the most common for Java is something called Javadoc. And this is a sample Javadoc, and it's at least it's predictable in terms of how it's organized. Java developers are used to this. They know how things are organized and they can find things. Basically, it lists the classes, and then for each class you can see what methods and fields are available, things like that. There's another popular one called Doxygen. This is more often used with C++, although you can actually, if you have a C# code base or a Java code base, you can use Doxygen to create the output as well. It can parse a lot of different languages. The syntax used in reference documentation is nearly identical. There are some slight differences, but for the most part it follows similar conventions. And developers actually, they usually don't generate these manually. What happens is in their build process, so when they have their code uploaded to a source control repository and they initiate a build command, they've got some scripts that will hook into the code and automatically generate these files. So a lot of this is just invisible to the developer. All they often worry about is just adding some often unintelligible descriptions and so forth within the code. If you want to see some good examples of source-generated documentation, go to this site, dropbox.com/developer/core. And if you look at each of these, Python, Ruby, PHP, Java, Android, iOS, you'll see that most of them are generated through various document generators specific to that language. And so they look different because these document generators, it's hard to skin them. I mean, usually you just leave it at the default and just take it as it comes out, although some allow a little bit of skinning. Now there are lots of pros of actually keeping the documentation in the source code. One is mainly that it avoids something called documentation drift, which is the idea that your documentation becomes less and less accurate in describing what your API does. In contrast, if you actually have your documentation in the code, not only is that much more convenient for engineers, but a lot of these document generators enforce certain things. You can't necessarily list a parameter without that parameter being present. You'll get errors and so forth. So there's actually some validity checking that goes on through these document generators. And they integrate very nicely into the developers' toolkits. They're IDEs, integrated development environments where they code, just kind of work well. A lot of times you'll see little tooltips. You can click links and go to the actual information. But there are some cons with platform APIs. Although they perform faster and they're more secure in general, it's harder for people to get all the coverage of all the languages that their audience may have. Languages are proliferating, and having a Java API, you're only going to hit a small segment of your market. There's going to be lots of people who want C++ and others who want .NET and others who have some other language variant. And so it's kind of hard to do the platform APIs in the kind of programming landscape we're in. And then also upgrades are a pain. Once people install your API and they've got it integrated into their code, they've deployed it, QA'd it, gone through configuration management and all this stuff, and you have an upgrade and you ask them to reintegrate your API, they have to go through the whole process again, and they hate doing that. And so you end up with users on all kinds of different versions, and it makes support more difficult as well. So there's kind of some major deficiencies with platform APIs, which has in part led to the growth of web APIs. Now these are the APIs that are much more friendly and familiar, friendly with technical writers and familiar on the web. Programmable Web did a study, and you can see that in the last, 7 years or so, these web APIs, or REST APIs, they're really synonyms, have exploded. They've really taken off. They have a directory at Programmable Web, and it has about 12,000. This slide is actually a little old. They have about 12,000 APIs. That is just a huge number of APIs. There's APIs on virtually anything. For example, I think the NFL has an API. Professional sports leagues have APIs, and newspapers, the Washington Post has an API. You can really, a lot of these companies, they want to put out an API so that other sites can pull in their content and can interact with them. It's part of the whole Web 2.0 phenomenon where you don't just have independent standalone websites, but you have kind of an interconnected web of data, and the APIs facilitate this. So let me get into, actually let me pause here briefly and just see if anybody has any burning questions they want to ask. Go ahead and just bring them up. Or actually let me check my little chat window. Okay, let's see if there's anything. All right. Well, if you do have questions, feel free to jump in and I will answer them. Yep, I'll give you a link. Okay, so some basics about REST APIs. They're called web APIs because they work pretty much like websites work, how the web works. In a regular web, in the web model, you type in a URL and you get back a web page. And if you type in "I'd rather be writing," you get back my latest posts. Well, with a REST API, it works the same way. You go to a specific URL, you pass it into to your browser, and you get back a bunch of information. This is Flickr's API, and this is a request for getting public photos. You can add different parameters to the request. So usually with the ampersand, you can add things like format equals JSON, and API key equals such and such, and like limit equals 2, or whatever it is that the endpoint, which is what they're called, allows. So there's basically a lot of different resources on server, and you access them through something called endpoints. And these URLs that I'm highlighting here are just endpoints, and the actual yellow part there are just parameters, configuration parameters to the endpoint. So knowing what parameters you can include with an endpoint is actually a huge part of REST API documentation. This is what developers need to know. What are the names of the endpoints, and what are the limits? What are the data types? There's usually things are a lot trickier. They're not as straightforward as they seem. When you're demonstrating how to make different calls, different endpoints, when you're demonstrating how to use the different endpoints, they're often demonstrated through something called curl. Curl allows you to basically pass an endpoint through your command prompt, through a command line terminal. You can add different methods, as they're called, to do a get, a post, a put, or delete. So for example, with that Flickr photo, if I were to do maybe a delete, I could actually remove something through that endpoint. So there's different actions. Different endpoints allow different actions. So let's get into a real example here. So let's say that I want to get a gallery of photos. Now right off the bat, you'll notice that the reference documentation, which this is flickr.galleries.getPhotos, is very, very sparse. What exactly is a gallery? There's also a concept of albums, and the reference documentation makes no attempt to clarify that. Reference documentation is usually very minimal. It turns out a gallery is actually kind of like a themed grouping of random photos, or not random, but throughout the database on Flickr, not necessarily a sub-selection of your own account's photos. So anyway, you can see that you've got some arguments here, API key, gallery ID. These are different parameters you can add to the endpoint. So here's how it kind of breaks down. The endpoint itself is flickr.galleries.getPhotos. Once you add all the values, there's usually a base URL that you add. And then these different values, the API key, gallery ID, which is critical, the format, and then no JSON callback. This one is specific to Flickr. I think it allows for JSON to work across browser. And then you get a response. And the response in your browser will look like this if you format it to look pretty. But of course, computers usually compress everything. So this in reality is usually minified in the response to make it faster. Now, if you look at the response, I was requesting a gallery. And so this is, to break this down, the response is a photos object. And then inside the photos object, there are a bunch of photos. But they don't actually have the URLs to any of the photos. If you wanted to kind of embed them on your site, you have to kind of figure it out. And there was nothing in the endpoint that actually describes how you construct a URL to each image. So this is where the user guide comes in. When you start to read the user guide, you find out that the response actually has 4 different components: a farm ID, a server ID, an ID, and a secret. And if you stack them in the right order, then it creates a valid image source. And then you can use that image source to put your photos. So this is an example that although a lot of attention gets paid to the reference part, actually the user guides are incredibly important, and that's usually what technical writers focus a lot on. And here's the result of my image gallery. I've actually displayed it on a page. You can go to that URL at wp-content/api-demo/flickr.html, and you can see the code. I actually have a lot of examples on my site if you just note this later. And you can go through some examples with Cloud, Eventbrite, and so forth. A lot of them are similar. There's also, now this is something that you probably haven't heard of. I was playing around with this last night. But you can convert your own help information into an API. Now this is something, I guess, that I only know how to do on a platform called Jekyll, which is a static site generator. But basically, there's a plugin that will take all your pages and format them as in JSON. So you can see JSON has key value pairs. You've got title, :about, URL, and so forth. So you publish that, and then all of a sudden, you can write some very simple code that says if the page URL is such and such, then get the photo or get the text and append it to a certain part on my web page. And here's an example. So if you want to see an example of that, go and check it out. It's just kind of a twist. Usually with API documentation, we always talk about documenting the APIs, but here you can actually convert your own documentation into an API that an application or a tutorial then uses. And it's probably only helpful for context-sensitive help. And you can get more details on my blog. It's actually the latest post. Now, one thing, if you remember at the beginning, I talked about I talked about platform APIs and how you have document generators to automatically take all this markup in the source code and push out a document. Like a mini website. Well, with REST APIs, Autodoc solutions are not nearly as common. And that's partly because with web APIs, they can be written in any kind of language. All the user cares about is that when they go to an endpoint, they get some kind of response. So because there's such variety in the way that people code the REST APIs, there's not kind of a standard mapping that these document generators rely upon. Different languages have different syntax rules and ways of writing things. So in general, most REST APIs, they their reference documentation is written manually. There are a couple of exceptions, and you'll see these. One is called Swagger, and it tries to create an Autodoc possibility. If you write and describe your API in a specific format, you can see it on the left. It gives you an example of the format it has to be in. Then it can take that spec, as it's called, and manipulate it and transform it into something that looks like this. You can see that it's got a list of the parameters, and description, data types, but it also actually lets you generate an endpoint. So you can try it out. You can just plug in values, hit that try it out button, and see the response in real time based on your data. There's another REST API modeling language, I skipped over the slide a little minute ago, called RAML, REST API modeling language. And it's like a competing spec to Swagger. It does highly similar things, but it's supposed to be in a more human-readable format. Now here's an example. There are other tools besides what you can do with Swagger and RAML. This is an example from Autodoc from Mashery that Clout, another service, is using. And here you can see that once you're logged in, your API key is automatically kind of entered, and you can just start using this. It's kind of like a little API explorer, if you've seen those, where you can just try out the API using your own values and see the responses. And here, as I mentioned, the USA Today has an API, and you can use their documentation like this to see what kind of value or what kind of responses you can get. And a lot of people ask me questions about the Swagger, and I'm by no means any kind of expert on this, but basically Swagger actually means a lot of different things to different people. It's the most popular of these auto generators, and you can either use Swagger as a library that's integrated into your code, or as a separate JSON file that describes your API. All right, let me pause here and see if there are any questions, anything somebody's dying to know here. Can you explain some more about how turning your documentation into an API will be useful for context-sensitive help? Well, with context-sensitive help, typically what developers do is use some tooltip library, integrate it into their code, and then the content for the tooltips is often in the code as well. So when a tech writer wants to jump in and provide that code, he or she usually has to send it to the developer in a text file, and then you never see it again. Well, this way, instead of sending a text file to the developer to just add to the code, you tell the developer to put some unique IDs in each of the fields. And then you supply a JavaScript file that triggers when somebody clicks on a button that has a unique ID, or there's different ways to integrate it. But basically, you give them a JavaScript file that then calls functions that will grab information from your JSON-based API. I know that probably is kind of cryptic, but if you go and check out the latest posts on my blog, I'dRatherBeWriting.com, there's code samples and more detail about that. And by the way, it's kind of it's just kind of a new technique I was exploring, because I found this tool that would change my help into JSON. Remind me what JSON. Sorry, go ahead, Faye. Yeah. Yeah, so what is JSON? JSON is just a format that consists of key value pairs. Let me see if I can go back to a slide here. There we go. So this is an example of JSON. All it is a format. It's not a programming language. It doesn't do a whole lot. It's just a more efficient and quick way to transmit information. It has largely replaced XML as the means of of transferring information. So almost every XML in the programmer sense, not necessarily for documentation or anything. Yeah, it just so usually a REST API returns information, and it's gonna format that information in key value pairs that looks like this, and this is called JSON. It stands for JavaScript Object Notation, but that doesn't really mean a whole lot. Yeah, and it's kind of interesting, like the way you pull out the information. Like, let's say you want to grab the ID of one of the photos. You use something called dot notation. Let's see if I have an example. I don't actually show the code. Oh, here we go. This is an example with the different scenario, but you can see where it says data.entries. It's actually accessing like one of the keys in the key value pairs in the JSON format. So anyway, just look up JSON.notation, and that's how you grab specific parts of the response. Yeah, it's a standard form. Exactly, it's a standard format for transmitting information across the web that programs can parse and understand. So yeah, definitely. Let me just see if there are any other questions I'm missing here. Okay. All right. All right. Let me jump back in here. Let's see where I was. Oh, okay. I was about ready to launch into some survey questions that I had done. So in order to just give you a broad overview of API documentation, I present some responses to various surveys, and this was a very informal survey, actually poorly done survey, but it's still somewhat informative. And there's great information from a group on LinkedIn called API Documentation and other places that really participated. But what kinds of APIs do technical writers document? Well, about nearly 80% of people are working on REST APIs. And of course, they have multiple APIs at a company, so this doesn't like add up to 100 or anything. But Java, C++, .NET they follow in the most common. But by far, REST APIs are common. And how many of the people documenting REST APIs are using an Autodoc tool like Swagger? Not that many, maybe 30%, but really the majority are not. They're documenting it by hand. Or if they are doing the automation, a lot of them have custom scripts, homegrown frameworks, and things like that. What kind of authoring tools do API doc writers use? And this is an interesting question. Most people, there was no like trends. It was like one-off responses. People are using different tools for different situations. The only trends were Confluence, Raw, HTML, Data, and Flare. So Confluence is often used as an internal collaboration tool in departments. I'm not really sure if people use it for publishing to an outside audience or not. So, but anyway, these are some popular tools. Do you test out all the API calls in the doc yourself? A lot of people do, about 55%. But a lot of people don't, because sometimes the APIs they're quite complicated. If you try to test out the different classes in a Java API, it's there's a lot to it. You know, it's not necessarily just passing an endpoint in your browser. It's compiling a whole Java app and knowing how to program, essentially. What IDE do you use? Now, an IDE is kind of like the editor that developers use when they code. And a lot of people are using Eclipse. It's by far the most common. It's free, it's open source, it's highly extensible. There's all kinds of plugins. Works with Java, C++, and some other languages. But then if you're in a .NET shop, you're going to be using Visual Studio, so that's also represented there. The most common programming languages that tech writers know are Java, JavaScript, Python, C++, C#, and PHP. So these responses actually reflect the most popular programming languages on the web as well. If you look and kind of search this out, this is a mirror image. So if you're trying to start out, most people will recommend that you learned Python and JavaScript, then maybe Java or C++. But anyway, don't spend your time on something that isn't going to give you a lot of value, because it can take months or years to learn a programming language. How many developers are actually writing the documentation in the source code? Here's an example where the question is highly vague, because if you have a platform API like Java, you're usually going to say yes, but if you have a REST API, you're usually going to say no, and I kind of failed to make that distinction in the question, but about 35% are actually writing in the source code. So this means as a tech writer, you're going to be interacting a lot in the source code. And a lot of the technical writers in the survey are familiar with programming languages, so they're technical. Do you write doc by looking in the source code? So I'm just kind of curious to see how many people are actually diving into the source code, getting in there, getting their feet dirty and their hands wet and so forth in actual code. About 60%. So this is definitely one of those spaces where if you want to excel, you really need to be tech savvy. A lot of API doc writers are actually former software engineers. About a third of them, I think, in this area. And why do they turn from software engineering to tech writing? Despite probably, no doubt, a lower salary maybe. Some people find it enjoyable. They may have struggled through all kinds of terrible tutorials when they were learning programming. They kind of like the more relaxed pace of tech writing and less pressure, and you get to be more expressive and so forth. How do you get the source code, right? Because developers don't just keep these in Word docs on a shared drive. They use source control. And Git is probably the most popular. It's partly because it's what people use when they're working with a web-based API. But also Perforce, SVN are popular, and a lot of people just don't have access to the code. Maybe the developers don't want to give it out. The most difficult part of API doc, people say, is understanding the code. The second most is getting information from engineers. And then a few others: creating the non-reference docs, understanding the audience, and identifying dependencies. So by dependencies, what we mean is what requirements are needed to use a certain class or endpoint before you can actually get any value out of it. A lot of times these endpoints or the classes, they're not standalone, they're helper utilities that are preparatory to using a different endpoint. So there's a whole workflow, and that workflow is not explicit in the reference documentation usually. How do you learn what you needed to know? Well, you learn a lot from developers themselves. Other people, they teach themselves. They use online resources. And as I mentioned, a lot of them used to be engineers. But by and large, in order to figure out a lot of the information, you're just going to have to learn it on your own and be bold enough to ask engineers. There's really no other shortcut. A lot of these online courses are going to get you familiar with something, but they're not going to allow you to understand production level code, which is what your developers are going to have. And you usually don't. I don't mean to paint the picture that you have to understand production level code. A lot of times, just knowing a little bit and being familiar with the lingo terminology is enough to make good contributions. Okay. So, some takeaways. You want to get started and ramping up your technical skills. Java, Eclipse, Git, these are all popular. I don't know why the slide keeps advancing. REST APIs are by far the most common. And I also think REST APIs are a great starting point for technical writers because they're not nearly as programmer heavy. Trying to understand a Java API is a lot harder than trying to understand a REST API, because essentially with a REST API, you can just document what the endpoints are, the parameters are, and what comes back in the response. You don't necessarily have to know a programming language to actually write the documentation. Each of the users actually will, for the most part, know how to make REST API calls in the specific language they're using. Okay, so let me pause here, see if there are any questions, things people want to ask me. Somebody likes Eclipse. Documentation is less buggy than code. Alright, well, if you have anything, jump in, or I will keep going. And one of the things that I guess I love to do is explore different publishing tools. I think one of the main things about being a tech writer that I like is that we control the whole authoring and publishing process from beginning to end in a lot of scenarios. You may be in a large company that handles all the publishing and so forth, but in most of my jobs I've been able to control all that. So when you're publishing API documentation, what are some trends? What are some design trends? What are patterns that the developer audience prefers in contrast to a mainstream end user who's not technical at all? Well, one of the most popular APIs in terms of an example API is one called the Stripe API. And people like it because it's got these code responses right next to kind of the descriptions of the different endpoints. And this is sort of set a design pattern. You see these kind of tri-column outputs quite frequently. And one thing the Stripe API does, which I'll get to in a minute, is they're going to dynamically customize some of the code samples based on your login. Another common thing is something called a single page scroll. Let me see if I've got an example. Here we go. Alright, so this single page scroll is an example where the document is really long and you just keep scrolling down, and on the left it's going to dynamically highlight your existing place in the document. This is actually a Jekyll theme that a company called CloudCannon is creating for API documentation. And they're modeling it heavily, you can see, after the Stripe API. But you can see that developers tend to like longer pages that have all the classes there at once with navigation on the left. This is maybe a design pattern that is implemented by Bootstrap. If you go to their site, Bootstrap is like a web framework that a lot of people use. You can see they've got this similar sort of setup where rather than having a million little pages, they just put everything, for the most part, on one page and give you this slick little navigation on the left that highlights where you are. And it's not too hard. Bootstrap actually provides a feature that will dynamically highlight it. It's called scollspy. I'm misspelling there, not scollspy. Alright, some other design patterns. You often see one seamless website matching the product branding. So it's highly customized. It's not boilerplate out of the box when it comes to REST APIs. And a lot of times you'll see navigation tabs that allow people to switch from one language to the next within the API, or within the documentation. So you can see here that there's a lot of different ways that people might take these endpoints and incorporate them into their code. And trying to provide code samples across 8 languages is kind of crazy, in my opinion. There are some tools, one called readme.io, that will actually auto-generate some of these code samples. I'm not entirely sure how it auto-generates them, but probably for more simplistic code samples, they're able to auto-generate them. So this is the Twitter API, and here's a common theme you'll see, is that you can sign in to the sites, and once you're signed in, your authorization key, your API key, is passed into other code samples so that you can copy and paste things more easily, or you can try out the API. And here's a screenshot from Stripe where they say, one of your API keys has been filled into the examples on this page so you can test anything out right away. So that's kind of cool. Developers like to copy and paste things. The guy who had worked on this readme.io platform for APIs said that a developer, when he or she is working on a site, usually uses between 8 to 10 APIs on average, and so the person is constantly going into these different sites and copying and pasting code. So anything you can do to make it easier is definitely welcome. Another major theme in API doc sites is providing a Hello World tutorial. A Hello World tutorial is just a sample first step with an app to get it up and running. Basically it's a beginner tutorial that gets them to actually launch something and do something. They're pretty much common in almost every API. There's even something called Time to Hello World, which is abbreviated TTHW, or First Hello World, Time to First Hello World. So people can rate an API based on how long it took them to get out of Hello World. So that's kind of a major thing. You'll also see a ton of code samples in API documentation. And the code samples are formatted with syntax highlighting, color codes different parts of the code, so it makes it much more readable. And there are actually whole syntax highlighting libraries that make this completely automatic. So these are just a summary of some of these trends. This third column to show responses in code, dynamic TOC highlighting, seamless website matching product branding, some navigation tabs, syntax highlighting, hello world. It's an interactive, personalized API Explorer, and what you don't see in a lot of these are that most of these sites, or a lot of these sites, are built with static site generators that process markdown syntax, which is a shorthand way of creating HTML. It's kind of like wiki syntax. Some non-trends, things that I don't really see a lot in looking at API documentation: it's PDF output, short pages, lots of multiple channels of content. So a lot of times in TechCom people produce 5 different deliverables specific to each audience. Well, a lot of times with at least REST APIs, there's one site and people come and get the part of the information they need from the site. Not a lot of DITA or XML authoring models. Most programmers prefer to work in Markdown because it's so much easier. Not too many EPUB formats, or even comments on pages, or wikis, or video tutorials, really. So now, I gave a presentation somewhat similar to this webinar, but not nearly as good. Just kidding. Just different. And you can download a lot of information. I went into a lot of detail about some other things. You can download them all on my site. I'll send you the link. Yeah, well, I guess I'm getting done here. I wasn't quite sure where I decided to end it. So, and I will make these slides and the recording available on my site as well for you all. Now let me check back and see if we have time for more Q&A. Wouldn't it be better to automate the documentation from a REST API? Why hasn't a tool been developed for this? So there actually is one tool that I didn't even mention that works with Java-based REST APIs. So if your REST API has a Java backend, then there's a tool by a company called Miredot, M-I-R-E-D-O-T, that will take and try to create a reference documentation. The problem is, and this may be personal bias because just being a technical writer, but the reference documentation for the REST API is only going to list all the endpoints and the parameters and the responses. What people really need are tutorials that teach them how to use the API, how to use it for real tasks. So I think if you, as well as provide code samples and other things, and if you have your reference documentation auto-generated, a lot of times you can't fit all these other details into it. And just, I guess the fundamental reason why is really that there's too much variety in the way REST APIs are created to make a standard mapping for the Autodoc to take place. Mm-hmm. Yeah. Oh, no, I wouldn't ever suggest dropping the reference, but a lot of times, um, well, let me give you an example from my past job. We had a REST API and we were using Drupal to publish everything. Everything from our blog to our support articles to our reference documentation and our tutorials. So we kind of put our reference docs in one spot and actually had a company build a custom plugin that would take and pull some information from the source files for uh, for the REST endpoints, and push that into JSON, which then Drupal could import. I mean, it was not like a $50 plugin or anything. It was some custom development that definitely took some people a lot of time, and then our engineers had to write a custom script to get the content into JSON. So it was this whole like custom process trying to move it around. And they're probably, the REST APIs are still somewhat young, maybe, and maybe that's why there's not more standard tooling. But the Swagger and the RAML are attempts to kind of provide more of the standard tooling around it. And yeah, I don't really have a better response than that. Yeah, go ahead. Yeah, well, the company that backs Swagger is called Reverb, Reverb, and the company behind RAML is one called MuleSoft, Mulesoft. And a lot of these companies, they go beyond just providing like a document generator type thing. They actually have a whole platform for your APIs. They want to, at least with the MuleSoft, they have all kinds of tools where you can actually have your whole API on their platform, and their platform hooks into it to generate the documentation and let users log in and have other kinds of tools available. So there's kind of a whole platform experience that people are trying to provide. What other questions you guys have about API documentation? Yeah, yeah, definitely. So just to sum up the question, you're basically saying, what are the criticisms of having engineers write documentation using in-source document generators? And I definitely have a lot of thoughts on that. One is people say that when you have a reference documentation that you've produced, so let's say it's Javadoc, and you give that to a customer, it almost gives them the illusion of having all the documentation they need. And the company may think, oh, I don't need to produce anything else. Here's the Javadoc for using our Java API. Well, what you really also need are these programmer tutorials or user guides that explain how to use the API. The Javadoc is usually not nearly enough for a developer to get started. There's no hello world. There's no description of workflows. It's kind of the equivalent of taking and documenting every tab in a user application without addressing any actual tasks that some user might want to do. Another pitfall is the curse of knowledge. And this is the phenomenon where somebody who has so much expertise in something fails to have the capacity to communicate in simple terms how something works to another person. If you imagine maybe somebody who's a really specialized lawyer who's got all kinds of intricate knowledge about tax law, and the person tries to explain to you something, and maybe the lawyer is incapable of putting it into terms, or maybe they just have so many assumptions about things you already should know that they can't see what they really need to document. And finally, definitely. Finally, I think there's lack of ownership with a Javadoc. If you have a team of engineers and each person maybe adds documentation for their class or their code, who owns the overall experience? Who's the person who's seeing if it all fits together, or if it's conflicting or redundant or what? There's it's kind of like a wiki where people write one page and they don't care about the rest of the content. So I think the more you can get into the source and start trying to contribute there, the better. It's really kind of hard to break into the platform-specific side, because in order to even understand what's going on, you have to have a foundation in that programming language. But once you get that foundation, then you can assess whether something is clear or what's missing. You can say, hey, this parameter, you haven't even defined it. A lot of times programmers they'll list a parameter name and they won't even describe it, or their description is like 5 words of the whole class or something. So you can at least ferret out the gaps in the documentation. And then there's a whole aspect of style. These document generator solutions have a very specific style about how things are worded. For example, with a throws exception, usually it begins with an if statement, that kind of thing. So you can go through and really structure and standardize the style as well. But I guess this is why I like the REST API side, is because it's less generated, less auto-generated. It's more in the hands of technical writers who can create really thorough, good documentation that not only lists all the parameters and different endpoints, but also has good code samples, cross-references, explanations, or links to explanations, and other detail on a more integrated experience. So definitely, if you're trying to get into it, go the REST API route. Okay, one question from Ursula. Any recommendations for those of us stuck with library APIs to make the accompanying user guides more interesting, useful, or shorter? Well, one thing that I think is pretty popular is to create some kind of reference implementation or sample app for your API and send that along with the code. You probably already do this, right? But it's kind of a 101 with the programmers. You send out your reference documentation. You send out a sample app that shows how you incorporate the reference app or the reference the reference classes or whatever in a very simple way. And developers love it. Usually they start with the reference implementation and build their own solution from it, rather than starting from scratch. So whatever you do, developers love code more than anything else, because it just tends to communicate in a very, very clear way to the developer, more than narrating and descriptions usually do. I once tried to make a video tutorial for code. they weren't received with very many hits that I could tell. So I think people sometimes don't really want to sit there and watch a video tutorial. They want to jump to code examples that address their situations. Any other questions? Yeah, and I actually love video, so I hate to even say that, but that's been my experience. And yeah, I'm sure there are more appropriate scenarios for video. Like if you're trying to show the result of the code. For example, Sarah Maddox showed how she created using the Google Maps API, using JavaScript. She then wanted to show the result and how you can maybe pinch and zoom or how it appeared, and that definitely is perfect for video. All right, well, any more questions? Hopefully you'll have a lot to think about, and there's definitely a lot of fun in this space. I know I don't mean to make it seem like you just have to trudge through really complicated code all day and work with engineers who are speaking really cryptic, short, impatient sentences. Really, it's a whole new world. It's a subspecialty, as Jim said. It's you leverage your skills, but it's also a lot of fun. It can inject a lot of new life into your TechCom career, give you lots of new things to learn, and become more of a power player in your ability to leverage different tools and do more creative things with them in the whole TechCom process. So definitely check it out and put it on your list of things to ramp up with and in your career. Again, if you want to get more information, I'dRatherBeWriting.com is my site. You can contact me online at tom@I'dRatherBeWriting.com or Twitter at Tom Johnson, and I'd be happy to provide more feedback. Thanks again, Jim and Greg.